Hello and welcome to our review of whole blood coolers and the individual components that make them up. So the purpose for this video is to help us standardize terminology used throughout the region, recommend current regional best practices, and help to identify any potential pitfalls that may lead to the loss of whole blood. The thermal isolation chamber, or the TIC. The TIC is a hard plastic container that contains a phase change material. The TIC requires conditioning before each use. To properly condition your TIC before using, all you're going to do is just take the lid off of the TIC and place the lid and the TIC inside of the freezer for a minimum of 24 hours. The freezer must be at negative 17 degrees centigrade or colder, which is slightly below 0 degrees Fahrenheit. Any standard freezer is capable of this temperature range. While some TICs used in the region may say that the TIC is conditioned after 8 hours in the freezer, just keep in mind that for whole blood, all of our evaluations have been done utilizing a 24-hour conditioning time. After your TIC has been conditioned for 24 hours, remove it from the freezer and then perform a bench conditioning. To bench condition your TIC, allow the TIC to sit out at room temperature for 15 to 25 minutes. What you're going to do is allow the layer of frost to form on the TIC and then melt away. After the layer of frost is melted away, wipe the TIC dry. It's now ready for use. Prior to each use, your TIC should be inspected as well. To inspect the TIC, all you're going to do is look at all of the seams, both on the container body and the lid, and what you're looking for are any cracks that may allow leakage of the PCM from the container. Also pay note to the manufacturing date, which is found on the barcode on the underside of the lid. It is the manufacturer's recommendation that TICs are replaced 5 years after the date of manufacture. Let's turn our attention now towards the vacuum insulation panels, or the VIP portion of the cooler. The VIP is a white cube that houses the TIC. This white cube is what provides the thermal barrier between the external environment and the TIC. The VIP is composed of 6 individual panels that are taped together. You should perform a daily inspection of your VIP whenever you switch your TIC. What you're looking for in this daily inspection is any damage to the VIP that may result in failure. Damage can be small pinholes in the panels to ripped or torn edges to a complete loss of vacuum. Normal panels are rigid to the touch. Panels that have lost their vacuum become very squishy. If you find any damage during your daily inspection, it is the Regional Whole Blood Committee's expectation that your agency replaces your VIP. Your VIP will also be embossed with a sticker that has a recommended replacement date on it. It is the Regional Whole Blood Committee's expectation that agencies replace their VIPs by the date indicated on the sticker. The last component of the blood cooler I want to talk about is the outer case. The outer case provides a layer of protection to the VIP. The outer case may be made of a ballistic nylon material or a Pelican hard case. So our overall blood cooler refers to a top-down assembly made up of 3 individual components: the outer case, the VIP, and the TIC. Before we wrap up, I would like to quickly talk about temperature monitoring. It is the Regional Whole Blood Committee's recommendation that each blood cooler has a dedicated temperature monitoring system in place. Pictured here is the TempStick, which offers wireless monitoring along with multiple programmable alarms. So what temperatures do we want to keep our whole blood at? Our desired temperature range is 1 to 6 degrees centigrade. It is our regional recommendation that agencies utilizing the TempStick set a high temperature alarm greater than 6 degrees and a low temperature alarm less than 1 degree centigrade. We also recommend a Wi-Fi connection alarm that will alert you should this TempStick drop offline.